Hello everyone, it's Mike Levin on Wednesday, July 13th, 2016 at around 8:30 a.m. And when last we left off, I took you from list comprehensions to generator expressions, the difference mostly being whether a square bracket encloses it or a parentheses encloses it. And I tried to make the point of how significant a light-in-memory generator expression is compared to, say, a list. And don't think I hit the point home quite well enough. And it's so fundamental to effective and elegant and memory efficient Python programming that I thought I'd write out a 10 million line file today and read it back in using a few different methods that Python makes available. I also noticed from my YouTube view count that the topic of generator expressions clearly is not as popular as many other things, such as just installing Jupyter Notebook and the advantages of programming in Python and all these other things that go up at a higher rate. You'll see that whenever I hit topics that are searched on in YouTube, the view count goes up quite quickly, which is sort of a shame in the case of generator expressions because they are one of the less discussed and more should be used features of the program of Python. So I'm going to create a new Python notebook and I will call it millions because we'll be writing out millions of lines essentially. And I have sort of jumped ahead. This will be a spoiler, but I want to teach you the with open command. So first thing is that in Python, simply opening a file, if it's actually there, let's call it small.txt. I like the irony because people want to say big. It's going to be 10 million lines. That sounds like big data. Well, no, that's still actually quite small data. And of course, the file is not there, so you get an error. So we give it a parameter W for writing. So open a file for writing. Suddenly it's there. And you can see you've got that pointy bracket notation. And you will also probably see the file there, 0 bytes. I should have done it before and after. But now we'll do it before and after. I just created that file. That would have been the equivalent in the Unix shell as typing touch space small.txt. To do this properly, I should have actually closed that file as well. And it's a very common practice to give a file handle like that. And if you do that, now you actually have something that you can close. And for many years and in many programming languages, this was considered the proper practice. If you opened something, you had to remember to close it. And Python, with all its wonderful structures for testing, had essentially created a derivative structure for opening a file that gets away with eliminating the need to do that close. I'll keep it there for a second just to show the before, but it's just basically with open as a file, colon, and now you have a block in here which just for the sake of having to have something in there, I'll put a pass, but that should be quite legit. There you go. And that's opening it for writing, but it's not really doing any writing because we're not asking it to. And the aFile object has a write method, so we could say write, that would be aFile.write. We'll just put one line, foo. Now we no longer have to pass, and we run that. And if we go over here, and I can open with text edit, you'll see the word foo in there. Remarkable. So, in for a penny, in for a pound, right? For, I guess, I in range 1, 0, 0, 0, 0, 0, 0. That's a million, right? Let's start out with a million. Be kind to our file. A file.write. Let's just write I. So that's a text file that will contain 1 through a million, but 0 base index, so 0 through 999,999, right? Okay, well anyway. Before and after. This is before, 3 bytes. Write argument must be string, not integer. Fair enough. The way we do that is %s, %i. This is string replacement. So that's essentially what people refer to as string literal with that strange term. This is a token representing replace me with what gets passed in. This is I'm going to do some string formatting and pass in stuff from a tuple. This doesn't need to be a tuple because it's just one character. Bam, run. How long does it take? Well, actually, the asterisk went away. That might have been it. Let's look at the after. 5.9 megabytes. Open with text edit. Text edit might not be my best choice. Maybe I should have used the more memory kind. Oh, look at that. So it puts it all on one line. Not good. Neither is using TextEd for displaying that. So I will fix both. We put a \n, rerun it, watch for the asterisk to disappear. That was writing 1,000,000 lines, ladies and gentlemen, which is why I named that file small. I'm opening it with Atom now, the much more popular text editor in GitHub. They say it's by GitHub. I don't exactly understand what by GitHub means, but this is my first time attempting to open a 1,000,000-line file in Atom as well, so I think it makes a thumbnail image over here of the overall file. Probably not a good idea with a 1,000,000-line file. I'm just going to attempt to quit out of that. Please don't ruin my video. Close. Anyway, as you can see, there's always issues with editing files like that. I'm going to open a new window, and I'm going to cd into this location. cd, let's learn Python from home. Vim small. And that's jumping to the end of that file in Vim. So as you can see, Control B for back for stepping through it, GG to the top. Vim is just a wonderful environment for all this kind of stuff. But anyway, that's other videos. Writing out 1,000,000 lines is really no problem. So what about reading in that 1,000,000 lines? Just as simple. It's basically the same syntax can do that, except it's going to be for a read. And similarly, we'll just put a pass in here, and you can see the same with open works for opening a file for writing or for reading. So this, what you're about to see, is reading that 1,000,000 lines. Because, they couldn't even see it go to the asterisk, could you? It might have the advantage of caching in there, but let's just pump that number up to 10 million. Watch for the asterisk to disappear. And this is on a circa 2011 Macintosh. This is a fairly old Mac doing that. That was writing out 10 million lines in a file. This is reading 10 million lines. This is loading it in Vim for editing and jumping to the end. What else do I want to show you in this tutorial? I look at my temp. Okay, with open I showed you. Yeah, of course, generators. So, generator expressions. One thing you would not want to do, well, first of all, remember, open small.txt, that alone has significance in Python. Don't forget that. That is a pointer to that file being opened. Now, the ways that you can open this vary greatly. One of the worst things I could imagine doing is putting square brackets around that, because that means is try and convert it into a list, and lists are loaded in memory at the same instant in time, so that because they're a mutable object and you can do all kinds of fancy stuff with them. But if you don't want to do all that fancy stuff, you can load it as a much more, dispensable, whoops, got that wrong. Parentheses. That is a more efficient way of opening it, because it turns it into a generator object. And when I showed generator objects earlier in here, where I used the parentheses here just to step through a few items, it really didn't make a lot of sense on that few items. Why use a generator object? Well, in this example, where we're handling a file that has 10 million lines in it, it makes a lot more sense. Now, I believe I'll get something if I do that. There you go. IO text, IO wrapper for read with UTF-8 encoding. So you can actually start to read these pointy bracket things and start to, learn stuff about the Python environment. This is not gobbledygook. This is actually informative stuff, even right down to that underscore. It's internal, but not so internal. But anyway, things you can do here. Just as if this were a list expression, a list comprehension, you can do x for x in. That is legit in generator expressions, just as it is in list comprehension. So, to undo that a few steps, in creating a list comprehension, your first step is those square brackets, and then x for x in. Not going to execute that, because that is a list with 10 million elements all loaded into memory. But I would not think twice about executing this, and watch how the pointy bracket stuff changes from just being a text IO wrapper into a generator object. And so now, how do you step through this highly memory efficient generator object? Well, there's probably a way to do it in one line, but on occasions you go back from your square and parenthesis bracket notation of creating list comprehensions and generator expressions to your more old school for let's see, a line in, for a line in, and I'll do pass, but this is the equivalent now of this. Now, which style is better? I guess that I leave up to you. There's a little bit of ambiguity in my mind that I'm going to resolve, that I do believe when you have a generator expression, it takes care of the conceptual step of closing the file, as definitely is happening with the with open statement. Oh, by the way, how big is that file now? That's an 80 megabyte file, see? But you're stepping through it quite this fast. Now it is 10 million, and I definitely wouldn't want to output something for every step there. But I guess since this is a similar syntax with map, reduce, and filter, if mod, no mod, Let's see, we have a line there, we have x for x in. X is what's in scope. X mod, I don't know, 10,000. If x mod 10,000 should be enough, because I shouldn't have to do any equivalency. That will evaluate true at every 10,000 units. Instead of passing, I will print. Yeah, print. Well, I want a counter. No, I'll just print a period. Now, because of output buffering, that might be a long wait and then a bunch of periods appearing, but why not? Oh, not all arguments converted during a string assignment. So, I guess it's coming back as a string, so we have to change that into an integer. There you go. Let's see if it's slowed down enormously. It probably has, but not that enormously. As soon as that asterisk disappears, we'll know it's done. But of course, outputting to the browser, and you can see the scroll bar scrolling here if it's not behind my head, you can see that this is tremendously longer than if just the word pass were in there, because outputting to the browser and showing it, it's actually overcoming the buffering, you can see, because it's creating that scroll. Has some cost to it. It's the longest part of this entire process. So it's counting to 10 million, and on every 10,000th row, it's printing a period. I guess I should have probably done something a little bit better, like outputting a numerator. And hey, why not? I'll try and get in enumeration here if I can possibly cancel this. Please don't ruin my video. Interrupt. I thought that's what the stop button was doing, but hey. Now we'll know we have it back if things speed up a bit. Well, let that be a lesson to us all. When you're dealing with 10 million lines of something, no matter how ideal situation it is, such as this situation where it's one line per number, per integer data type, there it goes. It's now at, the asterisk is gone. And I certainly don't want to do that again, but let's go back to pass and just do this for contrast. Stepping through those without any I/O takes that long. So it's an incredibly efficient way, and that's even with that filter calculation there. So once again, this is a continuation of what I actually demonstrated over here, where I went from the very popular topic in Python, list comprehensions, to the less popular but important to know concept of generator expressions, which actually relate to generators, which use yield. Boy, maybe I should have covered that here too. But made sure that you understood the significance of generator expressions by actually using it to open a 10 million line file and to zip through it like it's nothing. Now, of course, when it's real data files like CSVs that have multiple columns, the speed it's going to take to go through it line by line and parsing each line will be significantly longer, but what won't occur is clobbering your memory with, what it means to handle a 10 million line file, because generator expressions do not load it into memory at the same time, but essentially do what SQL people, I guess, are used to thinking of as a cursor in a larger data set. without ever loading the larger data set into memory, but you can move the cursor forward through it to scan the media, just like spinning a read-write head around on a hard drive. All you have to do is remember the location of that read-write head on the recording media and not load that entire chunk off of the recording media into your RAM memory, which is what clobbers things, as you saw when I actually tried to print even just a simple period for every 10,000 rows in a 10 million line file. So I hope that shed a little bit more light on what these generator objects and generator expressions really are and where they come into use. And again, why I so strongly encourage that you just internalize all this stuff as you begin learning Python, because it will serve you over and over in countless situations where things become mysterious and difficult to other people because they're like, oh, I'm handling this enormous file, and you shrug to yourself and you're like, oh, the size of the file is inconsequential as long as I can parse it by line, you know, I got it covered. So thanks for joining me. Hope to talk to you soon, and don't forget to subscribe.